This problem describes a solid of revolution created by rotating the given region about the y-axis, and we are asked to find the volume of this solid. We begin with a sketch of the region in 2D. For this, we need a y-axis and an x-axis. Let's begin with the line x plus y is equal to 6. If x is equal to 0, then y is equal to 6. And if y is equal to 0, then x is also equal to 6. So now we can draw a line through these two intercepts. Let's label this line. And now we deal with y is equal to the square root of x, which is our familiar root function that starts at the origin and grows something like this. And we also label it. And the last curve is y is equal to 0, which is our familiar x-axis. Now that we have sketched all three curves, we can shade the enclosed region and indicate the axis of rotation. We will also draw one general washer that will help us set up the integral to calculate the volume of the generated solid. Since we're rotating around y and we want to use washers, we will need a segment through the region that is perpendicular to the y-axis, like so, and now we can complete this to a washer. Here's our small disk, and here is our large disk. We could also shade it, so we get a better idea. In general, the volume with washers is given by the integral from, say, a to b of the washer area integrated with respect to the appropriate variable. Since our washers cut through the y-axis, we know that we must integrate with respect to y. Now, our washers also run from 0 all the way to this value that we do not know yet. Let's call it c. That means that our integration bounds run over the interval from 0 to c. The area of the washers are calculated by the difference of the large disk and the small disk. These are pi times, say, capital R for the large radius squared minus pi smaller case r squared, the radius of the small disk. Let us indicate these radii on the graph. So from the y-axis all the way to our blue curve, we have the large radius. And from the y-axis all the way to the green curve, we have the small radius. And since we are integrating with respect to y, we need to express both of these curves in y. That's easy to do. We simply solve for x. So we square both sides for the square root function, and we get that x is equal to y squared. What we need to understand right here is that this actually captures a little bit more than we were asked to graph. So this would be the full curve. For our line, solving for x, we simply subtract y from both sides and get that x is equal to 6 minus y. Lastly, we need to solve for c. Since both of our curves are expressed in terms of x now, we simply set these equal to each other. Let's bring everything over to one side, and we get 6 squared plus y minus 6 is equal to 0. We check if we can readily factor. If not, we would resort to the quadratic formula. But I notice that we can write this as y minus 2 times y plus 3 is equal to 0. And so we get y is equal to 2 and also y is equal to negative 3. Now we can see that our c value is that 2. And if we were to continue with our line, we see that this point here is where y is equal to negative 3. But it's irrelevant to this situation. Now we have all the information we need to continue with our volume calculation. So this is the integral from 0 to 2 of pi times the large radius, blue curve, so 6 minus y, all squared, minus pi times the small radius, so the green curve, y squared, all squared, integrated with respect to y. We take the pi out of the integral and expand the integrand, and so this is equal to pi times the integral from 0 to 2 of 36 minus 12y plus y squared minus y to the power 4 dy. We can readily find an antiderivative of each one of these terms, namely 36y minus 6y squared plus y to the power of 3 over 3 minus y to the power 5 over 5. And all of this needs to be evaluated from 0 to 2. Let us first notice that when we substitute for y the 0, we will get an expression that evaluates to 0. And so we're only concerned with the upper bound. So this becomes pi times 36 times 2, which is 72, minus 2 squared is 4 times 6 is 24, plus 2 cubed is 8 over 3, minus 2 to the power of 5 is 32 over 5. Performing the arithmetic, we will get as an answer 664 over 15 pi cubic units for our volume.